So here's the first. Can anyone help us differentiate that?
Negative 4 x minus 5 negative 3
times the inner function prime. I know I repeat myself and I know it's no need because it's 1, but always remember you have to say times the, okay, perfect. So this is negative 4 over x minus 5 to the third. We have to perform the same analysis. The second derivative equals 0 or the second derivative undefined. There is no discussion on undefined because it's undefined where the function is undefined. So is this ever 0? Is this quantity ever 0? No, because only the numerator could be 0, but 4 cannot be 0. Okay, now the next step is I have to study the sign of the second derivative. Okay, so let's plug in a number like 0 and tell me the sign here. So in this expression, plug in any number you want to the left of 5, not 5. It's undefined. So plug in anything to the left of 5, like, I don't know, 0, 1, negative 3, whatever you want, and tell me the sign. I don't need a number, I only need the sign.
Positive?
Yes, because with 0, this will be a negative number, and there's another negative. Awesome. Thank you very much. This implies holding water. When I get to graph the function, I have to make sure that it holds water. Now let's plug in a number to the right of 5. Any number you want, I only need the sign.
Is it negative?
Correct. With 10, this will be positive, but there is a negative in front. Which means make sure that the function does not hold water. At this point, I filled out my table. That's all I need. Nothing else matters. I don't care to look anywhere else. It will be a waste of time if I do. I only want to graph. And this tells me how to graph. Nothing else. I do not care about anything else. So when I graph, I have to start with the asymptotes. Always and forever, the asymptotes. Okay, so I see in my notes, I have that x equals 5 is a vertical asymptote and y equals 0 is a horizontal asymptote. Because it's y equals 0, it's an overkill, but I'm going to put it in. There is no need. I already have a line there. So this is y equals 0. 1, 2, 3, 4, 5. I have to graph the vertical asymptote. Now I'm ready to plot the points I have. You can say you don't have much, and that's true, I don't. So when x equals 0, y equals 0.4. Okay. The function increases, holding water, coming from the horizontal asymptote, crossing the y-axis, and going to infinity on the left-hand side of the vertical asymptote. It cannot be easier. Don't make it touch. Holding water. They should not overlap. I'm sorry, my markers are so thick. I'm sorry, forgive me. They should not. Let me try to make it super clear here. Okay. What will I do with it? If we run out of whiteout, I will be lost. Okay, so this is clear. Increasing, holding water, coming from the horizontal asymptote, crossing the y-axis at 0, 0.4, going to infinity on the left-hand side of the vertical asymptote. Now, on the other side, it's coming from negative infinity. It does not hold water. It has to look like this. It's increasing towards the horizontal asymptote. Fine. And here's the graph of f of x equals -2 over x minus 5. Now, if you want to check anything with the graphing calculator, then you have to be very careful, because I show it just for you to see it, but you don't need it at all. So be careful how you plug it in, however. You have to put -2, you have to divide, you have to put in parentheses, this is a must, x minus 5. Where is my 5? Here. And you have to, if it's different than 0, 0 is not necessary because it's there. But if it's different than 0, you have to create a new function with a horizontal asymptote. Okay? So, you know there is a vertical asymptote at 5. Some calculators do not show that vertical asymptote. I don't know if I don't think my software will show it. Here it is. Okay, so it shows the horizontal asymptote, but you see it does not show the vertical asymptote. It looks like, which is wrong, right? It looks like they overlap. The blue and the red, they disappear, so the function right here ends. No. You know it's not true. It goes on forever towards -infinity. So please don't copy a graph. The reason I'm showing this, please don't copy a graph like this saying, oh, I know how to graph, without showing the work. So if you practice this and you slowly determine the first derivative after you find all these values, and then slowly find the second derivative and study the sign, the table will tell you everything about the graph. It tells you where to start, where it crosses, where it goes to infinity, when it comes from -infinity, increasing, opening downward towards the horizontal asymptote. This is, I'm not minimizing the importance of this and the work that needs to be done here. It's huge, as you see. You have to think about all these values that we know from algebra. Then you have to analyze the first derivative. You have to set it equal to 0. You have to look at if it's undefined. You have to study the sign. Then you repeat for the second derivative. You have to be careful when you find the second derivative. And then find the sign and the potential inflection points. There is none here. And then you graph. Any questions? Any questions? I just want to, I know I have 2 minutes. I promise I'm going to stop. I'm not going to do anything. I just want to look at the function that we wanted to start working on. We're going to finish it up on Wednesday, 43. So I'm just going to copy the x minus 3 over x squared minus 2x minus 15. No, it's plus. Sorry, plus. Okay. So, can anyone factor the denominator for us?
X plus 5, x minus 3.
So now the domain. I'm going to stop. I'm just going to put in the domain, and I'll continue here next time. Can anyone give us, thank you so much, it was great. Can anyone give us the domain of this function?
-3 and 5.
Yes, so -infinity, careful, -5 and 3. -5, 0, 3, infinity. 0 has to be in the table no matter what. So you're saying that the function is not defined at -5 and 3. Is that correct?
Correct.
Perfect. So remember what we do. Nothing in there. You cannot write anything underneath this. You cannot write anything underneath this. And now, can anyone tell us what do these represent?
The vertical asymptotes.
Careful.
It's going to be only -5 is our answer.
X equals -5 vertical asymptote. And what will this be?
A horizontal.
Horizontal asymptotes can only be at infinities. We never discuss horizontal asymptotes before we find these limits. So that's the reason why I gave you this example ahead of time. When we simplify that factor, this is no longer a vertical asymptote but an open point, because I knew we would have to go and look at those. And I'll stop here.